All right, so last week, guys, our main topic of discussion was domain and range, what makes a relation a function, and the vertical line test. So those are the things we're going to kind of touch on today. Make sure we're rock solid on them, okay? Make sure that we're good on all of those things, and then on Thursday, we're going to add on to it. So the first representation of a function or relation that we talked about, one of them was ordered pairs. So in number one here, we've got a bunch of sets of ordered pairs that are all relations, and only one of them is a function. So remember, for a relation to be a function, none of the inputs can have two outputs, or none of the inputs can repeat. So remember, input is the same as x, output is the same as y. Okay, so all the x coordinates are the inputs. That's all we care about when deciding if it's a function or not. So looking at letter A, we're going to look at all the x coordinates. We have -6, 3, 10, and 3. Since 3 repeats, letter A cannot be a function because we have two of the same input and they go to two different outputs. For letter B, we've got -2, 5, 16, -3. Those are all the x coordinates. Those are all the inputs. Okay, they're all different. So B is definitely a function, but let's make sure the other two are not functions as well. For letter C, we've got 5, -3, -3, and 4. Those are all the x coordinates. Two of them are the same. Two of them are -3, so C cannot be a function. And last but not least, letter D, we're going to look at all the x coordinates. We've got 21, 21, 21, and 21. Not only are two of them the same here, they're all the same. So D is not a function as well. So B is our only function here, and just for review, even though it doesn't ask for it, we're going to identify the domain and the range of this function. The domain is the list or the set of all inputs. Okay, so I'm going to add domain to that line right there. Range is the set of all outputs. I'm going to add it to that right there. So my domain here is a list of all of the x coordinates. So in this case, it's going to be -2, 5, 16, -3. All of the x coordinates listed out. My range is going to be all the y coordinates listed out. So that's -1, -1, 3, -9. Okay. Does anybody have any questions about domain, range, or determining if something's a function from ordered pairs? All right, so we're going to move on to our tables right here. And our tables, if you look, they're x and y's, x's and y's, x's and y's, x's and y's. Again, x's are inputs, y's are outputs. We want to determine which one of these tables is a function. So again, we need to look at our inputs, our x's, and find which table has no x's that repeat. So looking at letter A, I have 1, 1, 2. Guess what? Two of them are ones, so A cannot be a function. B, my x's are 2, 1, 2. 2 repeats, can't be a function. Letter C, our x's are 1, 2, 3, all different. Even though the y's are the same, y's can repeat, x's just can't. C is definitely a function, but let's just double check D. Our x's for D are 1, 1, 1. Not a function because all of the x's are the same. Okay. Any questions on tables so far, guys? All right, so for domain and range of a table, we identify it the same way we do ordered pairs. The x's would be the domain, the y's would be the range. So my domain for letter C is 1, 2, 3, because those are all my x's or my inputs. Okay. My range for letter C are all of my y's, and it's the same number 3 times because all of them have the same y coordinate. Okay. Mappings are up next. So mappings are when we have two ovals or rectangles or just sets of numbers and there's arrows or lines connecting. So the thing on the left or the thing where the arrow starts is always the inputs, and where the arrows end up or the lines end up on the right, that's always going to be your outputs. This time we want to determine which one is not a function. So we're looking for the one that does repeat. Looking at letter A, my inputs are 1 and 2. 1 goes to 2, 2 goes to 1. Neither of these numbers have two arrows coming from it, so A is a function and won't be the answer. Letter B, 1 and 2 are my inputs. 1's mapped to 1, 2's mapped to 2. Neither of my inputs have two arrows or two outputs, so B will be a function and not the answer. Letter C, my inputs are 1 and 2. Both of them map to 1, but each of them only has one arrow. So because of that, C is a function as well. And last but not least, D is probably going to be the non-function, the one that's not a function, just a relation. And it's because 1 has 2 arrows coming from it. There's only one input, but it goes to 2 different outputs. So D is not a function. The domain and range for this relation, well, the domain is all the things where the arrows start, or the things on the left. So my domain for this is just 1. Okay, and sometimes the domain and range can be letters. That's okay, just write out what they are. The outputs here, range, 1 and 2. That's where the arrows end. Okay, any questions on mappings, guys? All right, so when it comes to graphs and determining if a graph is a function, we have a special test for that, and that's the vertical line test. So one of these is a function, the other 3 are not. Okay, so a circle, we've seen a circle before, and we know a circle is not going to pass the vertical line test because when I draw it, it passes through 2 points at any given point, really. Okay, so B cannot be a function by the vertical line test because any place I draw that vertical line, except for right on the edge, it's going to pass through 2 points. Square is kind of like a circle, right? So if I draw this line through the circle, or the square, I'm sorry, it's going to pass through a point at the top and the point at the bottom, just like the circle. So by the same rule, D is not going to be a function either. That leaves these 2 lines. Now, if I draw a line over this line, which is already vertical, there's so many points that I pass through. Any point on this line is the point on the vertical line. So because we pass through all these points, C cannot be a function either. Vertical lines are not functions. Which brings us to our last one, which we already know is the answer by process of elimination, but this is a horizontal line, and anywhere I draw a vertical line across the horizontal line, I only pass through 1 point at a time. Doesn't matter where I draw it, that's always, always, always going to be the case. So A is the function of these 4 graphs, okay? We're not going to go over domain and range when it comes to graphs. You guys are going to wait for that in algebra when you guys get to high school, okay? Last question is, which graph represents the table below? So we've got this table of values, x's and y's, and we want to figure out which graph it fits. Now, it's kind of hard to see because the numbers are super small, but scale is super important here. Letter A's scale goes up by 5 on the x-axis, so 5, 10, 15, 20. I'll write it bigger. Okay. This scale goes up by 1s, so 1, 2, 3, 4, 5. Okay. And this scale goes up by 1s as well. This y-axis goes up by 1s, so 1, 2, 3, 4, 5, while this one goes up by 5s. And last but not least, this one goes up by 1s, but it goes up more quickly. Okay, so we want to figure out which one of these 3 graphs fits this data. So the first point I see is 0, 0. This graph right off the bat, I can see it does not have a point at 0, 0. So I know C cannot be the answer. Okay. The next point is 1, 3. So if I go to this graph right here, I would go to 1. So this, since this is 0 and 5, 1 would be about here. 3 would be here. That point's not on my line. So I know that A is probably not my answer either. Just to verify, I'm going to go to 1, 3 here, and that one does work. 2, 6, that's 10. That must be 6. 3, 9, 4, 12, works out perfect. So all of these ordered pairs map to this picture, okay?